Hello everyone. Let's kick off with a puzzle. Imagine a marble rolling on the floor. You give it a push, and after some distance, it stops. People once thought that rest was the natural state of objects. Then came Galileo, who said, wait, maybe it stops only because of friction. He tested this with inclined planes. When the marble rolled down, its speed increased. When it rolled up, its speed decreased. With equal slopes, it reached the same height it started from. And if the slope was made completely flat and smooth, Galileo said the marble would keep rolling forever. Forever. That idea changed history. Motion doesn't need a constant push. If the total force acting is zero, then the velocity stays constant. Fast forward to Newton. He framed Galileo's observation into his first law of motion. The law states an object remains at rest or continues moving in a straight line with uniform speed unless compelled to change by an external force. That means a scooter parked at rest won't move unless pushed, and a cricket ball would keep rolling forever if there was no air resistance or friction. In physics language, when the sum of all forces, called sigma F, equals zero, then velocity stays constant. Force is required only to change motion, not to maintain it. Now, let's talk about inertia, the real star here. Inertia is simply the resistance of an object to change its motion, and mass is the measure of this inertia. In other words, inertia is proportional to mass. More mass means more resistance. For example, push a small cart and it moves easily. Push a train and nothing happens. Kick a football and it flies. Kick a stone of the same size and you might just hurt your foot. Why? Because the stone has more mass and hence more inertia. Now, hop into daily life examples. You're sitting in a car. The driver slams the brakes. The car slows, but your body tries to continue moving forward. That's inertia. Seat belts are designed to apply the force needed to stop you safely. If you're standing in a bus and it suddenly starts, your feet move with the bus, but the rest of your body resists and you fall backward. And when the bus takes a sharp turn, you feel thrown sideways because your body wants to keep going straight. Inertia is everywhere. It explains every jerk, jolt, and sway we feel in vehicles. Here's a fun demo. Stack carom coins on a table. Flick the bottom coin sharply. The bottom coin shoots out, but the stack above falls straight down. Why? The upper coins were at rest, and inertia kept them at rest, while only the bottom coin moved. This shows that inertia resists sudden horizontal motion, and a quick force on one part doesn't instantly move the whole system. Let's crunch some numbers to see inertia in action. Suppose you apply a force of 5 lakh newtons, that's 5 times 10 to the power 5 newtons, on a train of mass 2 million kilograms. Acceleration equals force divided by mass. So, acceleration equals 5 times 10 to the power 5 newtons divided by 2 times 10 to the power 6 kilograms. That gives 0.25 meters per second squared. The train barely accelerates. Now apply the same force to a car of mass 1000 kilograms. Acceleration equals 5 times 10 to the power 5 newtons divided by 1000 kilograms. That equals 500 meters per second squared. The car shoots forward like a rocket. The lesson? The greater the mass, the greater the inertia, and the smaller the acceleration under the same force. So let's wrap up. Galileo discovered that motion continues unless friction interferes. Newton turned this into the first law of motion. An object resists change, staying at rest or in uniform motion unless acted upon by an external force. Inertia is the resistance, and mass measures how much inertia an object has. Whether it's seat bells, grooves in teacup saucers, or the carom coin trick, inertia shows up everywhere. In simple terms, when the total force, sigma F, is zero, velocity stays constant. Only an unbalanced force can cause a change. So next time you fall forward in a braking bus, don't just complain, tell your friend, "That's Newton's first law teaching me physics for free." See you in the next session when we meet Newton's second law, the famous equation, force equals mass times acceleration.